periodic function has repeating output values at regular intervals. All of the 6 trigonometric functions are periodic. So let's take a look at sine, cosine, and tangent. And we can use the circle, the unit circle, to determine their periods. And the period is how long it takes for that behavior of the output values to repeat. So let's define sine on the unit circle. Just remind ourselves that sine of t is y, unit circle. And let's look at the y values. And it doesn't really matter where we start, but let's start, just at 0 degrees if we're thinking about standard position, and we'll start up this way. So as we work our way around the unit circle, we can see that we're looking for the output of sine of t is y on the unit circle. So we're looking for those y values. So what do the y values start at? They start at 0 degrees at 0, and then the y values start increasing as we go along the unit circle, because again, the y values are just the height. So think about, what height am I? I'm like a little bug traveling on the unit circle. What is my height as I go up, up, up? Okay, so now my height is at 1, but I've been getting a new height as I work my way around. So I'm definitely not repeating any values yet. Now I do start to repeat the values as I come down, but because I'm repeating them in a different order, think about it as like it doesn't count, okay? Because I want to not just repeat the same output values, but repeat them in the same order. Okay, so I'm not repeating those values in the same order yet. Now I'm getting new y values as I come and dip down below 180 degrees. So now I'm getting, my y values are getting less and less until I reach down to -1. Now I'm starting to repeat some of these same y values on this side, but again in a different order. So I really don't start to have the same behavior for sine until I get a full rotation, which in this case is 360 degrees or 2 pi. So the period for sine is 360 degrees or 2 pi radians. All right, let's erase that and now think about the period for cosine. So for cosine, we have cosine of t is equal to the x values for those points on the terminal side of the angle as we go around the unit circle. Okay, so the x value at 0 degrees is 1, and then the x values decrease until I get here at pi over 2. Right now my x value is 0. So if x values are continually decreasing, then they're not repeating themselves yet. Now the x values are getting bigger in the negative direction until they reach -1. So from 0 to 180 degrees, or 0 to pi, I don't have any repeating x values. Now I start to repeat my x values as I dip below 180 degrees, right? I'm going past it. I start to repeat some of these same x values, but not in the same order. These ones were getting closer and closer to -1, and these ones are getting closer to 0. So I'm not actually having a new, I'm not actually repeating the same behavior yet. And so now here I am getting some of these, some of these same x values down here, but these ones were getting closer to 0 as I went forward with my angle, and these ones are getting closer to 1. These x values on these points right along here are getting closer to 1. So I don't actually repeat that same behavior for the output of cosine until I get back at 360 degrees. So sine and cosine both have periods of 360 degrees or 2 pi. Now tangent is where we get a little bit more interesting here. So let's look at our tangent. Tangent is y over x on the unit circle. So let's think about how that might affect it. So it's the ratio of y over x. Okay, so let's start again at 0 degrees. And let's look at just in this first quadrant. In this first quadrant, my y values are getting larger and my x values are getting smaller. So I'm going to have different tangent values at all of these little points. So I'm not repeating any behaviors or any output values yet. Now over here, so let's think about what this is. This is positive, positive in quadrant 1. Now over here, I have negative, positive. So in quadrant 1, tan overall is positive, but in quadrant 2, so here tan is positive, but over here tan is negative because I have positive over a negative. So if tangent is going from positive values to negative values, I'm definitely not repeating any tangent values yet down to here. Now we should note that when x is 0, right here at the top, tangent is undefined because dividing by a 0 is undefined. Okay, so now what about when I dip down here? So when I get into the third quadrant, now I'm at negative, comma, let's see, negative, comma, negative. All right, and this is actually where I'm going to start to repeat some tangent values. And let's go to one that we know, say like right here. And I'm going to look across, which is to this point here, which was a half rotation or pi radians before that. This point here, write it a little bigger, is root 3 over 2, comma, 1/2. Now, how does this point compare here? Well, there's so much symmetry on the unit circle. So we can see that here, negative root 3 over 2, comma, negative 1/2. Now I can see that the absolute value of the x's and y's are the same. And if I look at this point I have here in the first quadrant, I have positive over positive would give me a positive tangent. And here I'd have a negative over negative still gives me a positive tangent value. And so the output at this angle here, which I can say is 30 degrees, and then this angle here, which is a pi radians away from that first angle, is the tangent values are actually the same. And so it's because we have this ratio that even though the actual points are different, when we do the division, the negatives cancel out and give us the same output value. So, and we'll see that all the way around. So tangent actually has a period of 180 degrees or just pi. So the following equations are a consequence of the periodicity of these functions. And so we have sine of theta is equal to sine of theta plus 2 pi k, where k is an integer. And these are written with radians in mind here, but we can also think of it with degrees as well. So we could write this as, say, sine of theta is the same as sine of theta plus 360 degrees times k, where k is an integer. Sometimes we write it like this. This means like belongs to this set of integers. And we can do the same thing for these, except we would have, 180 instead of 360 there. All right. So what does this mean? Well, it just means that the sine of some angle, and then the sine of an angle that is some amount of 2 pi or full rotations away in either direction, and the same with cosine, those will be the same output values. Now for tangent, I only need to be pi rotation away, so we get those repeated output values more frequently. So let's try this out. So here I have cosine of 390 degrees, and so what this is saying is that I can go in either order. I can say cosine of 300, or either direction, cosine of 390 degrees minus 360 degrees, right? So I'm going one full rotation, where k, in this case, k would be -1, and that would give me cosine of 30 degrees. And I go, well, I just might be more familiar with where that is, right? When we fill out the unit circle, we fill it out for one, positive rotation starting at 0 degrees. So at 30 degrees here, the point is root 3 over 2, 1/2. And so this is root 3 over 2 for my answer here. So it's just saying that this output and this output are going to be the same. And sometimes I'm more familiar with this output from, say, like my unit circle or something like that. Tangent of negative pi over 4. So I say, well, I can add or subtract as many pi's as I need to for that input to become familiar. So why don't I try a negative pi over 4 plus pi? So this is tan of 3 pi over 4. And then I go, I remember where that is. That one's here. This point is negative root 2 over 2, comma root 2 over 2. And when I do y divided by x, these are the same, but one's positive and one's negative. So my answer is -1. And so this here is 3 pi over 4. Now, another way I could have done this is say, why don't I just go find where negative pi over 4 would be? Now, technically, we don't label it on the unit circle as negative pi over 4, but it's still there. If I labeled every possible angle on the unit circle for all rotations, it would be too crowded, right? I wouldn't even be able to see anything. So we just label kind of a few under one rotation. Now, could we have labeled Negative pi over 4 on the unit circle, of course. So here's negative pi over 4. I'm still going to this point, which would be root 2 over 2, negative root 2 over 2. And if I do y over x, I get negative 1. So you can use this idea of the periodicity to find these output values. You can also use just finding that place on the unit circle and then using the corresponding point.